Determine whether the following improper integral converges or diverges. If it converges, determine its value. So we got definite integral from 4 to infinity. Okay, because of this infinity, this is an improper integral. So 4 to infinity, let's take care of this improper in this way. So we're gonna go from 4 to some number, let's say b, and we let that b go infinity. Okay, and then we have 1 over this. Now we need to work on this definite integral, and eventually we take this limit. That means we need to find antiderivative of 1 over x squared plus x dx. Again, we have limits. Let me just do this, then evaluate at the upper limit and minus lower limit. Okay, this is a rational function, a polynomial, number on the top and x squared plus x on the bottom. Then the bottom factors, x squared plus x, if you look at closely, we can factor x out, x plus 1. So we can write this complex fraction as a sum of two partial fractions. So we need to use the partial fraction decomposition, okay, just to evaluate this integral. So we let 1 over, when we factor, we get x plus 1 equals, we got two factors, x and x plus 1. And these are degree 1, so we just write degree 0 or numbers on the top. So we let this one, then multiply through by this common denominator. That means the top 1 equals, these are distinct, so a times x plus 1 plus b times x. Okay, when we have two distinct, then we can do this work. Now we choose x values, okay, so that we can isolate a and b. Okay, the bx, if we choose x equals 0, this is 1 equals 0 plus 1, just 1, 1a, just a, plus b times 0, just 0. So a plus 0 is a equals 1. So that means a value is 1. In the same way, let's choose x equals, look at here, x and x plus 1, right? X plus 1 becomes 0 at x equals negative 1. So choose negative 1. So here 1 equals negative 1 plus 1, 0. So this term is 0 plus b times negative 1. Okay, because we are choosing x equals negative 1. So this is basically negative b equals 1, or this 0 doesn't count. Multiply both sides, find negative 1. We get b equals negative 1. So this fraction is, now we can rewrite this as, this integral was a over x plus b over x plus 1, and a is found to be 1, so 1 over x plus b over x plus 1. b is negative 1 over x plus 1. Okay, this is whole dx. Now we can integrate this one. We got two terms. Antiderivative of 1 over x is simply natural log of x, absolute x. This negative, positive, negative. 1 over x plus 1. Okay, derivative of x plus 1 is 1, so this is also natural log of x plus 1. Okay, antiderivative of 1 over x plus 1 is this one. But our x, if we look at this context here, we are working on 4 through infinity, only the positive. So the absolute values are not needed, because our x is eventually is going to be 4 through infinity, positive. Okay, so I'm not going to write absolute value anymore. And let's simplify this one. Okay, this integral, here we got difference of natural logs. So difference of natural logs will be natural log of quotient, this x over x plus 1. Absolute value, but I'm not writing because I know x is going to be positive eventually. So that is this integral using partial fraction decomposition, and plus c not needed. Now we need to work on this limit. Look at here, 4 through b, then we take this limit. So let me write over here. So this one is limit b goes to infinity. These limits of integration 4b, 4 to b, and this integration is found here, natural log of x over x plus 1. We can write parentheses if you like. Now let's evaluate this integral at the upper limit, this function at the upper limit, and then minus lower limit from the fundamental theorem of calculus. Replace x by b, so this is natural log of b over b plus 1 minus, replace x by 4, natural log of 4 over 4 plus 1, 5. Now we need to find this limit. If this limit comes out to be a finite number, then the integral converges. If it comes out to be infinity, or if the limit does not exist, then we say the integral diverges. Okay, limit is just here. Okay, only the first one. The second one is a number. Natural log of 4 over 5. This is a negative number, and this negative, and this is negative. It will be a positive number. Let's take the limit here. B is there, so it's like, let me recall something. What is the limit when x goes to infinity of x over x plus 1? If we directly plug in, that's going to be infinity over infinity, but then we can divide the top and bottom by the x. Okay, so this is going to be 1, and this is going to be 1 plus 1 over x. And when x goes to infinity, 1 over 1 plus 1 over infinity, that's 0. So to find this limit, the easiest way, this is a polynomial divided by polynomial. Okay, degree 1, degree 1. That means the ratio of the leading coefficients. We got same degree on the top and bottom. So 1 over 1, so this limit is 1. And earlier I was mentioning, okay, I just use the shortcut. Divide top and bottom by x. X over x is 1. X over x is 1 plus 1 over x. And then when we take infinity, 1 over 1 plus 1 over infinity is 0. So that's 1. Or same degree top and bottom, that means leading coefficients, 1 over 1. Okay, when we take this limit, that's going to be 1. So we get natural log of 1 minus natural log of 4 over 5. Okay, it's a finite number, the integral converges. We can simplify, by the way, natural log of 1 is 0. No need to write that. So minus ln over 4 over 5. That's the final answer. By the way, natural log of 4 over 5 is a negative number. And this negative in the front will make everything positive. If you don't want to write negative, then optionally you can write natural log of, if you flip this fraction, 5 over 4, this produces negative sign, and negative, negative, positive. So natural log of 5 over 4 or negative natural log of 4 over 5. Or you can think negative 1 move up, and then that means reciprocal. Final.